Example 5. Given g of x equals -3 log base 2 of the quantity x plus 1, let's first algebraically determine the domain of g of x. So for a logarithmic function, what that means is take the argument, which is x plus 1, create the inequality greater than 0, and solve for x. So this is a one-step problem. Subtracting -1 gives me x is strictly greater than -1. So that our domain in interval notation is -1 to infinity. Now we're going to graph g using transformation. So let's first identify our parent function. We'll just strip this transformed equation down to log base 2 of just x. So listing the transformations, the leading negative symbol is a vertical reflection. You could simply end there because a vertical reflection implies it's over the x-axis, but just to be abundantly clear, let's just say about the x-axis. The next transformation that I read is this number 3, and that's a vertical stretch by a factor of 3. The next transformation I read is the plus 1. Well, that is in the argument. It's quote-unquote happening to the x, so that's a horizontal shift left 1 unit. So what happens to the x values? Well, we just take every x value and subtract 1. I'll just write that in parentheses. What's happening to the y values? Well, there's two things happening. Technically, we're multiplying by -1 and we're multiplying by 3, but we can just be a little more concise there and multiply by -3. So I'll write that as take -3 times y, but technically that's two transformations. So let's list the key points of the parent function, and that was log base 2 of x. So remember, that's positive 1/2 because the a is 2 and the y value is -1. We have the x-intercept of 1, 0, and then we have the base, and the exponent of 1 gives us 2. Now with our transformations, -3 log base 2 of the quantity x plus 1, for every x value I'm subtracting 1. So 1/2 minus 1 is -1/2. 1 minus 1 is 0. And 2 minus 1 is just 1. Now for the y values, I'm going to do both transformations in one step of multiplying by -3. So -1 times -3 is +3. 0 times anything is still 0. And +1 times -3 is -3. Now our original vertical asymptote was x equals 0. So because it's an x equals statement, anything I did to the x, I also need to do to the equation of the vertical asymptote. So we subtracted 1. 0 minus 1 is -1. So I'll start as I graph that. Excuse me, I didn't mean to jump around on you there. I'll sketch in the vertical asymptote of x equals -1 first. And then as I sketch the graph of -3 log base 2 of x plus 1, I'm going to take those 3 points There's my x-intercept of 0, 0 now. And then I had 1, -3. Let's say that's about here. 1, -3. And I had -1/2 and +3. So that would be about here. This would be -1/2, +3, and that just kind of went away on me for some reason. And then I know that I'm going to have a decreasing function, so I'm going to connect those dots with a ramp shape and indicate with arrows that it goes on and on in both directions. So let's look at the range and the domain here. We know the domain in part A was given as -1 to infinity. And now looking at the graph, I can read the range that it's still all reals. So from -infinity to infinity.